In the previous lesson, we looked at using the angle-angle similarity postulate to prove triangles similar. In this lesson, we're going to look at two other ways to prove triangles similar. The first method is side-side-side similarity. It's kind of like the side-side-side congruent theorem, but instead of proving the sides congruent to each other, we're going to prove the sides proportional and conclude that the triangles are then similar. The second way is side-angle-side similarity. And in order to use side-angle-side similarity, our included angle still has to be congruent, because between similar shapes, all the angles will have to be congruent. But instead of the sides being congruent to each other, the sides need to be proportional. So when we have side, angle, side, proportional, congruent, proportional, those triangles will be similar. Let's take a look at some examples. In this first example, I have two triangles in my diagram. I'm going to redraw these two triangles. I'm going to start with this smaller triangle. And then I'm going to redraw this larger triangle. And the reason I'm going to redraw them is so I can get a better look at each one individually. Now both of these triangles share this vertex. So that means that they share an angle. So this angle will be congruent between those two triangles. We also know that this side is congruent to this, or excuse me, parallel to this side. Since these line segments are parallel, I'm going to get congruent angles. So this angle will be congruent to this angle because they're corresponding angles between parallel lines. And these angles will also be congruent because they're corresponding angles between parallel lines. So are these two triangles similar to each other? Yeah. And how would I prove that they're similar to each other? Well, I have 3 pairs of congruent, or three pairs of congruent angles. I only need 2 to use the angle-angle similarity postulate. Second example. Again, I have 2 triangles. So I'm going to redraw both of those triangles. And the reason I'm redrawing those triangles is so I can get a better look at each one individually. Again, those 2 triangles share this angle, so I have a pair of congruent angles between those 2 triangles. But what I don't want to do is assume that these 2 line segments are parallel. I don't know that they are. I don't want to assume that they are, so I can't make a conclusion about these angles. What I can do is look at the side lengths. This side length is 6, and this side length is 10. Now if I go to my bigger triangle, this side length is 6 and 3. 6 and 3 gives me 9, and this side length is 10 and 5 for a total of 15. So it kind of looks like I have side, angle, side. But I need to check to make sure that my sides are proportional. To do that, I'm going to set up a proportion. And I'm going to compare which sides might be similar. 6 I'm going to compare to 9, and 10 I'm going to compare to 15. And I'm going to check that proportionality by cross-multiplying. 6 times 15 is 90, and 9 times 10 is also 90. So this proportion checks out. So this side, 6, is similar to this side, 9, as this side, 10, is similar to this side, 15. Notice that instead of using a tick mark to mark these sides congruent, I'm using a squiggly line that looks like the similar symbol. That means that these sides aren't congruent, but they're proportional. So yes, these triangles are similar to each other, and the method that I would use would be side angle side similarity theorem. And the last example, I have two triangles, and I don't know anything about the angles, so I don't want to use any theorem or postulate that involves angles. What I do know about is side lengths. And in order to figure out if the sides are proportional, I have to decide which sides to compare. Now if I look, I don't know which side to compare. 8 looks like it lines up with 9, and 16 with 6, and 12 with 12, but that doesn't quite work out. I need to come up with a method to figure out which sides to compare. To do that, I want to look at the smallest sides and the biggest sides and the middle sides. And I'm going to set up ratios for each one of those. So my smallest sides. The smallest side in my first triangle is 8, and the smallest side in my second triangle is 6. And my middle sides. In my first triangle, 8, 12, and 16. 12 is my middle side. And in this second triangle, 9 is my middle side. And 16 is my biggest, and 12 is my biggest. If you look, these triangles aren't drawn to scale. They're labeled correctly, but they're not drawn to scale. Make sure you're checking out the numbers correctly, and you're comparing smallest sides to smallest, and biggest sides to biggest, and the middle sides to the middle sides. Now I'm just going to use a calculator to find all of the decimal equivalents of these ratios. 8/6 as a decimal is 1.3 repeating. 12/9 as a decimal is 1.3 repeating. And 16/12 as a decimal is 1.3 repeating. And I can compare 1.3 and 1.3 and 1.3. Notice it's tougher to compare these numbers when they're not in lowest terms, but I can compare decimals. So 8 is similar to 6, and 12 is similar to 9, and 16 is similar to 12. So are these triangles similar to each other? Yes, by the side-side-side similarity theorem. We're going to kind of switch gears and look at a problem where we have to solve for x. In order to solve for x in this problem, I first need to know that these two triangles are similar to each other. So I have a small triangle with side lengths 15 and x, and a larger triangle with side lengths 15 plus 24, which is 39, and x plus 16. Make sure that this length is not written as 16x. It's not 16 times x. It's x plus 16. And both of these triangles share this angle, so I can mark those angles congruent. And I also know that these sides are parallel, which give me corresponding angles that are congruent. So yes, I know that these triangles are similar to each other. If they're similar to each other, all of their sides will be proportional. Now that's important because I can then set up a proportion to solve for x. I'm going to compare 15 with 39. And I'm going to compare x with x plus 16. Now to solve, I'm going to cross multiply. and then solve for x. 39x equals 15x plus 240 minus 15x divide by 24. X is going to equal 10.